We now have two types of displacement, velocity and acceleration, linear and then angular. However, the picture is not quite complete. We learned about a third type of acceleration earlier. It was when we covered uniform circular motion. There's a hint. What is it? Centripetal acceleration. We covered that back in the uniform circular motion chapter, just like the hint I gave last slide. And if you'd like, you can go back there and review it. It's the acceleration that a point on a rotating disk feels that keeps it moving in a circular direction. Or it's the acceleration of a planet going around the sun. And it's equal to v squared over r. Now this v is the v we've been working with this chapter, where it's the tangential velocity of a point on a rotating disk. Up till now, in this chapter, we've called it linear velocity. We're going to rename it again by taking advantage of its tangential nature as we discuss acceleration. Look at the disk below. That shows the linear acceleration. That's what we've been dealing with here. And we're renaming that now for our purposes a sub t for tangential acceleration. And then here's our centripetal acceleration, which as we know points right towards the middle. The angular acceleration, actually, we represent like this. We talked about how it's positive and negative, but it's also a vector, and it either points into or out of the page. Don't worry about that now. We're going to talk about vectors pointing out and into the page in the electricity and magnetism section of this course, and also next year in APC mechanics. So we have three accelerations. Centripetal points towards the middle, tangential points tangent to the circle, and then we've got angular acceleration, which is either going into the page or coming out of the page. These two are our linear accelerations, centripetal and tangential. We now have three accelerations associated with a rigid rotating body: tangential, angular, and centripetal. So here's tangential, a sub little t, alpha, which is angular, and here's centripetal. And they're all related to each other. So the challenge to you now is to express all three of these accelerations in terms of the angular velocity omega of the rotating object. Give it a try. Start with these three equations, work with them, and express each one of these variables in terms of omega, the angular velocity. So if you'd like, pause the video, work on it for a bit, and then come back, and then we'll pull down the screen. Okay, you're back. Here comes the screen. Well, screen's going away. Tangential acceleration is r alpha, but alpha is change in angular velocity over change in time. So here we go. Here's tangential acceleration. Our centripetal is v squared over r. V is r omega. We square this, we cancel out an r, and we have centripetal acceleration is r omega squared. And then we just have the definition of alpha, which is change in angular velocity over change in time. So depending on what problem you're working, you'll use one of these three equations or one of these guys. And the only way to know which one to use is by practicing problem solutions.